Hi guys, it's Penguin Design here with another tutorial to add to the Pong series. Before I begin though, I'd like to apologize if the video is a little bit laggy. It's just because I'm recording on my laptop. The audio on the other hand should be the same. So, what we're going to be doing in this tutorial is creating an executable file type, which means that it can be run and played on your computer. Not only this, but you can also send it to your friends. So, if we look at it, we can see that it is an application, and if we double click on it, it will bring up this configuration window in which we can set its properties and hit play. Now here's our finished product that we're going to be making in this tutorial. So as you can see, we have a main menu, which is different to before, with a play, exit button and a title. As you can see, we have this ball bouncing around here. That's because interactive elements often make the main menu more fun. Not only this, but I decided to add some code to make it so that whenever you clicked, it added another ball. This helps add a little bit fun to even the most mundane elements of the game. So as you can see, if I click on the play button, it expands, and then when I release, it takes us into the game that we're familiar with as we created it in the previous parts of the tutorial. So we're going to open up Unity and open up the previous project that we were working on. For me, that's Pong Part 4. Once we open this, if you just see this blue window here, then double click on the Scenes folder and open up Level. As you can see, we have the previous game that we've worked on just working perfectly. So, what we're going to do is go File, New Scene. Don't worry, this won't delete any of our progress, it will just create a new scene in which we will make the main menu. So if you click on your main camera, you can set its background color. This will directly correlate with everything in the game view. So just like in the actual game, we're going to set it to black. Now what we're going to do is go up to Game Object, create 3D Object Cube. This is going to be the borders that you might have seen on the edges in the main menu. This will also act as bounds for the ball to bounce off. Currently, if you look in the game view, it's a grey color, but we want it to be white. There's an easy fix for this. Just go into your project view, click on materials, and then drag on the enemy material. This was a material that we created in the previous tutorials. Now, if we click Reset under the transform, it sets its position back to 0 on each axis. Now, if we highlight it in the scene view, a useful trick is if you press Ctrl on your keyboard and start clicking and dragging on this green arrow, it will snap it to an absolute integer position on the y-axis. So what we're going to do is move it until it's just over the edge in the game view. That's not quite close enough, so I'm going to change it from -4 to -4.5. As you can see, that is lining up perfectly. Not only this, but it's the wrong scale. If we click up here in our toolbar and click the Scale tool, it will bring up squares rather than arrows. If we again press Ctrl, we can click and drag and make sure that its scale is fitting to the edge of the screen. So it should be a number like 18, but it doesn't really matter. What we're now going to do is duplicate this so that it's on the top. So press Ctrl D for duplicate, and now again you can just move it up while pressing Ctrl to snap it to the values. Now we're going to create the borders on the left and right hand side. So what we can do is again duplicate this cube over here, and then rotate it so that it's 90 degrees. The control trick also works for this. Now I'm just going to move it to the left until it hits the edge. It looks like -8.5 will work. I'm also going to change its scale so that it's not quite so unneat. There we go. Now if we just duplicate it, we can move it over so that it's on the other side. Now, in our scene view, we have a box, and in our game view, we have a nice border. Unfortunately, in our hierarchy, we have a whole lot of messy names that don't really make any sense. So what I'm going to do is hit game object, create empty. The reason I'm doing this is it's the equivalent of having folders in Windows Explorer. Imagine if in this PC you stored absolutely every file on your computer. That would be unbearable. So just like in Windows Explorer, in Unity we use empty game objects as folders. I'm going to reset its position and then name it walls. Now if I use Control on my keyboard, I can click on individual cubes and drag them onto the walls to make them a child. Making objects a child means that whatever properties this has, these also have. For example, if I moved this wall object, it would move all of those cubes. Unfortunately, it still isn't neat, so I'm going to select all of the cubes and name them wall. Now that we've got that, we can begin adding in the text. So, in our previous tutorial, we imported a pixel art font, which I'll provide a link in the description to download if you haven't already. We're going to be using this font for the titles. Simply click on Game Object, 3D Object, 3D Text. As you can see, this looks atrocious. Not only is it low resolution, but it's not exactly the text that we want. So we're going to change this to say pong. Although it still isn't quite what we want. The way to fix this is under Font, drag in the pixel art font. Now, if you notice, the text has become massive. That's okay. What we're going to do is set its scale to be smaller. So as you can see, we have a more manageable size. I'm going to set his scale to be 0.05. Now in our scene view, we can use the arrows to align it to what seems to be the center of the screen. -4 looks okay. Remember, this stuff is optional and just helps make your game look even more professional. So, now that we have the Pong text, I'm going to duplicate it, and instead of writing Pong, I'm going to write New Game. Because this is a subheading, we want it to be much smaller. So instead of 0.05, I'm going to set its scale to 0.02. Now, like before, we can position it inside the game. The positions don't have to be exact. Anything that fulfills the aesthetic value that we're trying to achieve will work. Press Ctrl D to duplicate this text once more and move it down and simply rename it to exit. Now we can position it so that it's in the center. There we go. If we look in our game view, we have exactly what we want. The only problem is if we press play, it currently does nothing. For example, if we click on New Game, it doesn't take us to the game. And if we click exit, it doesn't exit. So let's begin to do that. Now we're going to be doing some coding. So if you open up your scripts folder, right click to create a new C# script. In this script, name it exit. This will be the code that's attached to the exit object. So simply open this up in your IDE of choice. Mine is Visual Studio. So now we'll be presented with this. So let me give you a brief overview of what all this means. These two lines over here saying using unity.engine and using system.collections allows us to write all the code that we know and love. Public class exit extends mono behavior, stores two things. Not only does it store the name of our script, which is exit, but it also tells the computer that it keeps every mono behavior script. I'll provide a link in the description for a better explanation on how extending classes works. For now, we can delete all the code in between the class exit. What we're going to be doing is calling two functions. The first will be called on mouse down. This is just the name of the function. Usually we could call a function whatever we want. In this case, onMouseDown is a specific function that Unity calls whenever the person presses the mouse button down, not up, but down on the object. So now we can just open and close empty parentheses, as this function does not take any parameters. And inside the body of the mouse down function, we're going to write one line of code. So this is going to say transform. So what this transform means is it's referencing this property over here. Dot local scale. So we're targeting the scale parameter. And now what we can do is go times equals 0.9. Oh, so what does this actually mean? So first of all, we already know what transform.localScale does. It lets us change the value of the scale of the object that this script is applied to. In this case, it would be the exit. But what does this times equals 0.9f mean? It seems like another language. Well, what we're really doing is multiplying the scale of the object by 0.9. For example, if the scale of the object is 1, we'd set it to be 0.9. This will make it so that when the person or the player presses down on the object, it becomes smaller. Although it's tricky to understand, it is a very useful way of coding. Next, we're going to create a new function. This again will be a void, because as you noticed in our onMouseDown, we never had to write return 0. So this one will be a void, and it will be called onMouseUp. So this will be called when the player lets go of the mouse. So once again, it will take empty parameters. And in this one, we're not going to be changing its scale. What we're going to be doing is making it so that the game closes. The way to close the application is to go application.quit. This is quite self-explanatory. So now if we save our code and we go back into Unity, what we can do is select our exit object that has the text mesh with the text exit. And just for neat's sake, I'm going to name this exit, but once again, this is completely optional. And I'm going to do is drag on the C# script that we just made. So if we press play, unexcitingly, when we click on the exit, nothing happens. The reason for that is, it doesn't know where our object actually is. The way to do this is to go to Add Component, Physics, Box Collider. If you look in your scene view, it will add a green square around the exit. You can simply adjust the size by changing the value of these variables. This is once again optional, but it helps add some polish to your game. So now if we press play and we click on our exit, it becomes slightly smaller, and when we release, what a surprise, nothing happens. The reason for that is that when we build our game, it's an application. But in this state, we're just playing it in Unity. Because else it would be really annoying if every time we clicked exit, Unity closed and we had to reopen. So just trust me in the fact that when we build our game, the exit will actually start working. So now what we can do is create another C# script, this one called new game. So now what we're going to be doing is creating similar code to what we did in the exit.cs. Now, you could easily just copy and paste this code, but so that you guys learn a bit more, I'm going to rewrite it. So, once again, we can delete all these functions as we're not using them. And we're going to create a function of type void, as it does not return a value. This will be onMouseDown. Once again, we know that this is called when the player clicks on the object. Now, once again, we're going to change its scale. So we're going to write transform.localScale times equals 0.9f, semicolon. That one's a bit of a tongue twister, but trust me, it works. Now we can have another function called onMouseUp. I'm just going a little bit quicker because we already know the way this one works from the previous part of this tutorial. But here's where it gets a bit different. Because this is attached to the New Game button, we don't want it to quit the application when we click New Game, do we? So how do we open the level that we made? Well, this is when the advantages of scene comes in. What we can write is application.loadLevel1. So, once again, we're referring to the properties of the application with this line application. And load level, that's quite self-explanatory. It's just telling Unity to open up a scene. But why have we got 1 here? Well, I'll explain. If we click on File, Build Settings, you can see this large section up here called Scenes in Build. Currently, it's empty. Now, we need to fix this because else this code will give us an error. What we need to do is first go File, Save Scene As, and save this scene as Menu. Now that we've done that, we can go back to File, Build Settings, and click Add Current. As you can see, there's a small number next to it. If we go back into our Scenes folder and open up the level scene, and then go File, Build Settings, and click Add Current, you'll see the 1 next to it. That's why we want to open the level 1 whenever we click on the New Game button. So, now that we've done that, we can simply save our code, go back into Unity. So now we can select our New Game object. So now we can go Add Component, Physics, Box Collider. This just helps Unity recognize the on-mouse down and up function. Now we can drag on the New Game script. If you get this error, it's a simple fix. The reason for this is that the name of this, New Space Game, is different to this, New without a space Game. How do we fix this? We simply click on the New Game script in Unity and get rid of the space. Now, I think we can add it to the New Game object. Now, if we press play and we click New Game, then we release, nothing happens. But that's only because we haven't built the application yet. Once we build it, this will all work perfectly. Now we get to the fun part of the tutorial, adding the balls bouncing everywhere like crazy. Now this is once again an optional part of the tutorial, but I think it helps add a lot of fun. So now what we're going to do is in our assets folder, click on prefabs and the ball. What we're going to be doing is creating a different version of the ball. This will be the version that's used while in the menu. So what we can do is right click and choose Show in Explorer. Now press Ctrl C and then Ctrl V. Now it will create a copy of the ball. We can rename this Menu Ball. What we're going to do is change the properties of this ball. Instead of Is Kinematic, we're going to check Use Gravity. The difference between Is Kinematic and Use Gravity is kinematic means that it cannot move unless otherwise told so in scripts. We don't want this. We want it to act naturally. We're also going to select Collision Detection Continuous. Continuous just means that this ball is not allowed to go inside other objects. This just creates for a more realistic experience. Finally, we're going to create the code that tells the ball to move in a random direction. So we're going to go Scripts, right click, Create, C# script, Menu, Ball. Now if I open this up in Visual Studio, we can once again delete the default functions, and what we're going to be doing is defining a variable. A variable simply stores a value, just as much as a box or a container would. So first thing you have to do when defining a variable is tell it the variable type. This is going to be an int. So what does int actually mean? Int means that it can be a number from 1 to, I forget the number exactly, but it's a large number, so from 1 to almost infinity. But the exception is we cannot have numbers like 1.1. They need to be whole. They have to be like 1, 2, 3, 4, and so on. So now that we've chosen the variable type, we need to select a name for the variable. So this can be anything. You don't have to copy me. And I'm going to call it ball vel. This will be the velocity of the ball. Now we're going to set the value for this variable. Just for now, I'm going to set it to 500, but this really doesn't matter. Now that we've created the variable, we're going to create a rigid body. So what does this variable type mean? This isn't storing a number. In fact, it is storing this rigid body component here. So, now that we've got our variable type, we can name it. Once again, this is a completely optional name and it doesn't matter. So now we're going to create a function. This will be a void as it does not return a value. Now in Unity, the names of your functions are important. So this is going to be called awake with a capital A. So what awake means is this function is called once when the game, not when the game starts, but when the object is created. The reason we're not using start is that these balls are going to be created at different times when the player clicks. So now all we're going to do is go RB. So we are talking about this object and we're going to set the velocity. Now we're going to set it to a new vector 3, meaning it takes 3 parameters. Those 3 parameters are, so we're just going to be set it to ball velocity on the X, ball velocity on the Y, and 0 on the Z. This means it should move diagonally. Now we can save this code, close Visual Studio for now, and if we click on our menu ball prefab, we're going to click on this ball script, hit remove component, and add the script that we just made. This was called menu ball. So now if we add this object to the scene by dragging it in, we should see that it starts moving. There's a few things that we need to change, but that's easy. So, to fix this error that we just got, what we're going to do is reopen our menu ball script, and we're going to set both of these variables to be public. Public means not only defines the scope of the variable, but it also means that we can see it in Unity. So if we save that and go back into Unity, click on our prefabs folder and menu ball, as you can see we have the ball velocity variable and the RB present. Now this RB says none. The way we fix that is simply drag in itself. Now it will automatically select the rigid body from itself. If we drag it into the scene, we'll see that it starts bouncing around by itself. The problem with this is, as you can see, it's emulating real-life physics, and that is that a physical object will eventually lose velocity because of forces such as friction. The way we fix this is select all our wall objects, and under physics material select bounce. This basically tells Unity not to use physics. So now as we can see, the ball will not slow down unless it's stuck in between two objects. So we're done with the menu ball for now. What we're going to do is create a game object that spawns the ball. So I'm going to name it spawner, and all this is going to do is contain some code. This spawner script is going to be a little bit more complicated than the other scripts that we've made so far. so I'm going to be going a little bit quicker. I'd recommend not making this script if you're a beginner. So I'm going to name it spawner, open it up in Visual Studio. Now what we're going to be doing is deleting these comments here for the void start and void update. Now what we're going to do is define 3 variables. The first will store a random position for the object on the X and the Y. So we're going to go int rand X and int rand Y. This will be the position that the object spawns at on the X and Y position. Now next we're going to have a game object, and this is going to be called ball. This is going to store the prefab that we created for the ball. So in our void update we're going to say if input dot get mouse button down 0. This will check for a right click. Right click. Now we're going to call a function called spawn. We have not yet created this function, so it will tell us that something's wrong. Now we're also going to call the function in the void start. This is because when they start the game, we also want one ball to appear. So our void spawn is going to do 2 things. It's going to be a void, as it won't return a value. We got to name it appropriately, and it's not going to take any parameters, just like in up here. Now inside our spawn, we're going to call another function called create random position. Now we're going to create this function before we do anything else. So this once again will be a void, and this will basically set int x and int rand y and int rand x equal to a random value. So the way we're going to do this is we're going to use a function called random.range. Before we can do that though, we need to determine what range we are in. So I'm going to say from -8 on the x-axis from -8 to 8, and on the y-axis from -4 to 4. So we can go int x, rand x equals random.range. Now this is going to be, as you remember, between -8 and 8, semicolon. Now I can do the same thing with rand y, except instead of between -8 and 8, we're going to have it between -4 and 4. So that will be all for the create random position. Now what we're going to do is go instantiate, because we want to create the object. And now what object are we going to instantiate? Well, we're going to instantiate the ball. Whoops. Now if I remember correctly, it takes a vector3 position, as you can see here. So that vector3 position is going to be a new vector3 rand x, rand y, 0. Now we simply need to give it a rotation, which is just quaternion.identity, and we can just end this line. So now if we save, this hopefully should be all working. Now that coding was quite complicated, and I know that for beginners stuff like random.range and creating a whole lot of functions can be really difficult. So what I'm going to do is in the description add a link to somewhere where you can copy and paste the code. That's just because I think that it's a bit unfair to expect you guys to be able to do that if you're only a beginner. So now what I'm going to do is on my spawner, click add the spawner script, and quickly I'm just going to go back into monodeveloped and make this game object public. Now if we go into our prefab folder, we can drag in the menu ball prefab inside the ball. So now hopefully if all my code is right, every time we click it spawns a new ball. I'm just going to make a quick adjustment, and that is to set the scale of the ball to 0.5, 0.5 and 0.5 on the X, Y and Z. So now, as you can see, we have a whole lot of balls spawned when we click around. Another slight adjustment that I just remembered is that our exit and new game must have the bounce material, or else they will be applying friction to the ball and they'll all be slowing down. So now that's working perfectly. Just for aesthetic sake, I'm just going to lower the speed down so that it's a little bit more manageable, maybe to something like 30. There we go. So now we're going to do the process of building the game. The way we do this is it's quite simple. We go File, Build Settings, Player Settings. Now over here we select all the settings that the program uses. What we're going to be doing is under Supported Aspect Ratios, unselect all of them except for 16:9. This means that if the resolution is not in the aspect ratio of 16:9, like we've been working with here, it will force it to be. Now the other settings aren't important, but if you were going to make this a full-fledged game, it would be smart to include an icon. Now you can simply hit build it to, for example, your desktop. I'm going to name it YouTube. Now if we hit enter, Unity will compile all our code into an exe file. It will also package up all the assets into the exe file, and once it's done, we should have the icon on our desktop. So if I open this up, as you can see, we have this screen here that lets us select the resolution, and when we hit play, we'll have our menu, and like we worked on, if we click, it will create a new ball. If we click on exit, it will change sides, and then when we release, it will close it. And if we click on the new game button, hopefully it will take us, okay, it exited it. It looks like I've accidentally added the exit script to the new game object. These things happen, I'm sorry for it, but I do all this stuff live, so sorry about that. I'm going to add the new game script. Now I'm going to go File, Build Settings, Build, and I'm just going to rebuild the exe file. Now that it's done, if we open it up and we hit play, our play button will hopefully work. Yes, it is changing size and it's taking us to our game. So although it was quite a journey, and some of the parts of this tutorial I would definitely not recommend to a beginner, it did create a really pleasing result. So I'm really happy that you guys stuck along till the end of this tutorial. And I'm sorry if there were a few mistakes here and there, but I think in the end we created quite a good finished product. So I hope you guys enjoyed that tutorial series, and I'm signing off, so goodbye.